Hi, this is Dave Waddell with the King County Hazardous Waste Management Program. In this section of our talk, we're going to be talking about disposal of hazardous waste. Any teaching lab is going to eventually generate waste from the processes they're using. What do you do with that stuff? How is it safe to dispose of it? What can go down the drain and what can't? And if you can't put it down the drain, what can you do with it? We'll be covering that in this section. Okay, so let's get started on hazardous waste management from schools. And I realize this is probably one of the driest topics, and I'll try to spice it up a little bit so it's not just reciting regulations to you. Washington State has extremely rigorous hazardous waste laws. Only 3 states in the Union have hazardous waste regulations that are as stringent as ours are: California, Minnesota, and Washington. So I've posted on this first slide that there's ignitable and oxidizers and corrosive bases and corrosive acids and reactive compounds and toxic compounds. And all of these are the characteristics of hazardous waste. So things that burn at room temperature very readily, things that cause other things to burn, things that will corrode your skin if you touch them, whether they're basic like Drano or like an acid, things that if you spit on it, breathe on it, it bursts into flames, or if you twist the cap, it can blow up. And things that if you swallow it, you touch it, or you inhale it, can cause you to become either very sick or actually die. These are the kinds of characteristics we're worried about in the hazardous waste regulations. But the bottom line that you should know in Washington State is virtually everything in your school that is a chemical, if you try to dispose of it, is probably going to designate as a hazardous waste. It's kind of like mushrooms in the wild. The odds are not good that you just pick up some random mushroom and it's going to be edible. The odds are even less good that you would take any chemical you've got and throw it in a dumpster, and that would be a legal disposal option. So given that, let's talk a little bit about what you can do with this stuff. So can you pour your chemicals down the drain when you're done with them? Probably not. Again, most of them are going to be designating as hazardous waste, and you can't pour hazardous waste down the drain unless you've got a permit from your local sewer authority. They don't issue those permits very often, and you've got to pay a lot of money for it. And the reason they don't do this is the drains go to Puget Sound, or they go to local lakes or streams. And the treatment plants are also under restrictions from the federal EPA on what they can allow to go out into the receiving waters. So they don't want anything coming into their treatment plant that may cause them to be regulated as being an illegal hazardous waste disposer. They also want to protect their workers. And anything that does get trapped in there is going to go into the biosolids that may get applied to beer fields in eastern Washington. And I like really clean beer, so no dumping your toxic heavy metals into the drain. So what are sewer regulations like? Well, the treatment plant regulates it. So if you want to know, call your local treatment plant. You can figure that out by just asking your accounting department who they're sending their payments to as far as paying their sewer bill. The pH limits are usually between 6 and 9. Some of them expand a little bit, but unless you've got something that's between 6 and 9, it's either too corrosive basic, too corrosive acidic to go down the drain. Heavy metals are the ones that people tend to put down the drain, and the limits for what can go down are at the low part per million level, incredibly dilute before it's okay, and nothing that would designate as hazardous waste without approval. The other thing to understand is just because you can add a whole lot of water to something to make it more and more dilute doesn't mean it's okay. That is considered evading the intent of the regulations and is illegal at the federal, state, and local level. So unless the sewer utility has specifically written you something in writing that says it is okay for you to dilute this particular material and put it down the drain, you can't do it. So when I'm talking dilute part per million concentrations of heavy metals, what does that look like? Well, most science teachers are familiar with things in molarity. And the most dilute molar solutions we see people work with are typically 0.1 molar. So copper sulfate, one of the most commonly used chemicals in the science lab, you're working with a 0.1 molar copper sulfate solution. That's got to be okay to go down the drain, right? Well, let's work out the calculation. And when you do, you realize that 0.1 molar copper sulfate is 6,530 milligrams per liter, which is equivalent to part per million of copper. Most sewer agencies have a sewer limit of 8 milligrams per liter for copper. So 6530 versus 8, you're 800 times the allowable concentration of copper that can go down the drain. Now, you could always try to dilute that pint of 0.1 molar copper sulfate you've got with 800 gallons of water if they say it's okay. course, then you're going to have to find someplace where you can hold 800 gallons of dilute copper sulfate before you discharge. You can't just pour it down the drain and leave the sink running. You have to treat it by diluting it first. I'm thinking you don't have an 800-gallon tank in your science classroom to do this. Cadmium levels even crazier. You'd have to have a 0.000005 molar cadmium solution in order to have it go down the drain. When I show this to science teachers, I keep getting the response, well, at 0.0001 molar, it's not going to do anything. Exactly. That's why it's safe at that concentration. So if I can't pour it down the drain, maybe I can evaporate it. Well, it's okay to evaporate your waste if it's the water that you're evaporating out of it, or if it's a completely empty container where you've poured everything you can out of it and you're just trying to dry it out a little bit. Aside from that, no way. So you can't evaporate your flammable solvents, even though they're volatile. That's illegal disposal under the Clean Air Act. So if I can't pour it down the drain, and I can't throw it in the trash, and I can't evaporate it up in the air, what can I do with it? Well, there are some options that you have prior to disposal that you can do. The first one is if you've got acids and bases that are contaminated and you can't use anymore, you can dilute them very carefully, track it on a log sheet, neutralize them, and then pour them down the drain if they don't have any heavy metals or other types of contaminants in it. For the aqueous metal solutions, more than just a drop on a sheet of paper that you can wipe up with a paper towel, these can be evaporated. My recommendation is that you track this on a log, so if somebody like myself, who's a hazardous waste inspector, comes in and says, so what do you do with your metal solutions? You say, oh, we properly dispose of them. It's like, prove it. If you've got a log sheet saying what you're doing and you have records and receipts from the disposal, then I'm going to be convinced. Other than that, I'm thinking you're either pouring it down the drain or you're dumping it in the backyard. So keeping a log sheet shows me as an inspector that you're doing the right thing. And schools are regulated exactly the same as any other business. There's no exemption for schools under the hazardous waste regulations. So you can be fined and penalized and all of that stuff just like any other company can. So what I recommend for the aqueous metals, which is the most common waste stream you probably have, from your science labs at least, is to get a Ziploc type baggie, a good size one, line a beaker with it, pour any of these liquid metal solutions you've got into that bag and let them evaporate. 99.5% of the solution you've got is water. So you're reducing the volume by 99%, which is going to save you a lot of money. Once you've filled the Ziploc bag with sludge, zip it closed, lift it out of the beaker, put it into a plain 5-gallon paint bucket, snap the lid on, and write the words hazardous waste, heavy metal salts on the top. When that bucket's full, then you can dispose of that as hazardous waste. For a typical science lab, it'll take you 40 years to fill that bucket. It costs you about $250 to dispose of it. So $4 a year for your hazardous waste budget. It's pretty cheap. So I don't want to hear any whining out there about how tough this is and we don't have a budget. Trust me, you can afford this one. Solvents are different though. If you've got flammable solvents, those you need to collect typically back in the original bottle. So keep an empty solvent bottle around to use as a waste bottle. Write the words hazardous waste, flammable solvents on the outside, and then collect your waste solvent in there. If you can avoid having waste solvent, that's great. It'll save you some money. Solvents will go off to be burned as fuel, so it's not a real expensive disposal option again. As far as acids and bases, again, they can be neutralized. You need to track it on a log sheet. One of the ways you could do this, though, is you could actually do it in class, because if you're a chemistry teacher, you're probably teaching acid-base neutralization reactions. Why not use your waste acid for this or your waste base for it rather than something new? Now it's teaching. It's not disposal. You don't have to track it. You don't have to count it. Once you're done with that lecture or the experiment, then you determine whether the material is hazardous waste. If it's been neutralized between 6 and 9, go down the drain. Now there are a few acids that you can't use it on. Hydrofluoric acid, which we talked about in the high hazard chemical section, is way too dangerous to be doing acid-base neutralization. Perchloric acid, which is a very toxic compound and highly reactive also, is another one that you probably don't have, and if you do, you can't do this type of neutralization because the reaction can get a little too hot. Glacial acetic acid and ammonium hydroxide are two other corrosives that we don't recommend be neutralized just because they generate a lot of very stinky fumes. And you really wouldn't want to have the ammonia vapors flying all through your lab. Now, I always get asked about alcohols. It's like, okay, alcohols can't go down a drain. What's that about? And the point is well made. If you go to a typical bar, the example I always use is, I'm at the bar. I order a scotch on the rocks. They deliver the scotch. I look in, one of the ice cubes has a fly suspended in it. I give the drink back to the bartender. What does the bartender do with it? Well, alcohols are considered ignitable hazardous waste if they're over 24% in concentration. They're flammable liquids. They're federally regulated by the EPA as a flammable hazardous waste. So a bar is a business. So he takes back the martini or the drink that he's given me, the scotch on the rocks, and he goes, all right, let's see, I guess excuse me everyone, I'll walk into the back room, I'll find a 55-gallon drum of flammable liquids, I'll very carefully pour it in there and close it, I'll write the accumulation start date and start disposing of this as hazardous waste. Does the bartender do this? Absolutely not. As a hazardous waste inspector, do I get to inspect bars? Absolutely not. Kind of looks bad when the county vehicle's driving up to the front of the local tavern and I disappear for an hour to do my very in-depth inspection in there. So are you going to get busted by a hazardous waste disposal inspector if they catch you pouring a little bit of alcohol down the drain? Probably not. However, as a well-trained hazardous waste inspector, am I going to recommend that you pour your alcohol down the drain illegally? Absolutely not. You should collect it like large generators of alcohol do. Collect it as flammable hazardous waste, ship it off for disposal. One thing you can do that's pretty sneaky, though, is there's a great laboratory exercise you can do with alcohol, where if you take 100 milliliters of alcohol and 100 milliliters of water and you combine them, they don't add up to 200 milliliters. They probably add up to maybe 180 milliliters. Now, how does that work? Well, it actually involves the molecular structure of these two compounds. And if you happen to have the dilution in that process be such that you end up with less than 24% alcohol in with the water that you've combined it with, again, it's not waste disposal, it's not dilution. What you're doing is showing this chemical property. At that point, when you're done using it as a teaching tool, now it's a waste. For something to be hazardous waste, it has to be a waste, and then it has to be hazardous. If at the point where you say, all right, this is now a waste, I can't use it in my curriculum anymore, if it's less than 24% alcohol, it's not hazardous. If it's not a waste, hazardous waste, you can pour it down the drain because it's completely water soluble. So that's a way not necessarily around the law, but a way to actually use your waste alcohol as a product, so it's not really a waste. One of the things I want to mention here is that you can't just dispose of hazardous chemicals any which way you want. If it's an acid, it's going to go to a commercial site and be neutralized. If it's flammable, it's going to be going off to be incinerated. If you've got an unknown compound, like our don't smell here, you don't know what the hazardous characteristic is. If you don't know that, you cannot get it taken away from you for disposal. And if it spills, you don't know how to respond to it. So unless you know it's hazard, you can't dispose of it. And if you don't know the hazard, you're probably going to pay somebody else to figure out what those hazards are. Those type of tests can be very expensive. Unknowns can be found in old labs, like this one that's down in a basement. And they could turn out to be extremely explosive. They could turn out to be water. A clear liquid like this ethyl ether is a potentially explosive compound. It looks exactly like water. So the clear liquids and the white powders in a laboratory setting are ones that pose particular risks if they're not labeled. So label your chemicals so you can ensure that they're properly disposed. If you do find explosive chemicals and have to pay for disposal, it's very expensive. And I mean very expensive. Thousands of dollars per bottle potentially. There's a variety of options that may be available depending on where you're located. Some places they blow it up. They'll take the material out, shoot it with a gun, not you, a professional, shoot it with a gun and have it detonate. You're not allowed to do that. Shooting hazardous chemicals is kind of forbidden under most laws. But if you've got a sheriff's department or a bomb squad, that may be what they do. They may wrap it up with detonation cord off-site. The challenge, of course, is trying to get it out of your school, out to a place where they can do that. You know, shooting it inside the school is really not recommended. There are chemical deactivation contractors, which is what we've been using in King County. They're under a state contract, and you can contact me. I'll be providing my contact information in just a second about how to get a hold of these people if you should find bombs at your site. Check around before you start looking for these things to see if your local sheriff's department, hazmat team, maybe the local university that's nearby has a bomb squad that can provide the service for you. You want to know about this before you start looking around for these things so you know how to respond to them if you find them. The blow-up option is best for things like the peroxidizable solvents because they actually get completely consumed when they do explode. Picric acid is not a good choice because if it's moist at all, what you're going to end up doing is spraying picric acid all over the place. Then it's going to get dry, at which point now you've got millions of tiny little bombs scattered wherever the explosion happened. The next few slides show what the chemical deactivation contractors look like. They wear 17 layers of Kevlar body armor. They have self-contained breathing apparatus. In other words, they're much better prepared to deal with this stuff than you are. Don't try to do the deactivations of these things on your own. Even though you may be a chemist, it doesn't mean that you're equipped to properly and safely handle these things. The other thing to consider, and the last slide here shows a link to our less hazardous laboratory downloads that we have at the King County Rehab Lab website. If you can avoid using chemicals that are going to be hazardous in the first place, you're not going to generate any hazardous waste and you're not going to have to pay for that type of disposal. So you think about using small-scale and micro-scale chemistry and using these less hazardous labs at our safe labs that don't pollute website. If you have any questions about this information, please feel free to give me a call. Again, my name's Dave Waddell. You can email me at dave.waddell@kingcounty.gov. Thanks.